Notes for 2.8, graphing linear and absolute value inequalities. So we're talking about inequalities here, so we're talking about greater than or equal to, less than or equal to, greater than or less than, that kind of thing. So when I got my linear inequality, I got y something mx plus b could be greater than or less than or greater than or equal to or less than or equal to. Any of those can go in that box. Absolute value inequality. So we got the same thing here, y something, a, my absolute value, x minus h, plus k. And it could be any of these again that you're plugging in the absolute value inequality parts going in there. Which of the following are solutions to this thing? You're literally just going to plug it in and see if it's true. So 3 times 6 plus 4 times negative 3 greater than 8. Okay, let's see, we got 18. 18 plus negative 12 greater than 8. 18 minus 12 gives me 6. Is 6 greater than 8? No. So that means no, it's not a solution. Simple as that. Let's do the next one. 3 times 0 plus 4 times 2 greater than 8. This goes away, so I got 8 greater than 8. Is 8 greater than 8? A lot of you are going to want to say yes, because they're equal, but since I don't have that equal bar, no, 8 is not greater than 8. They're equal to each other. Let's see if we got one that's going to be a yes. 3 times negative 3 plus 4 times 5 greater than 8. So I got negative 9 plus 20 greater than 8. 11 greater than 8? Yes. There's my solution. That one right there. Graphing linear inequalities. Okay, so we always want the y on the left. We always want the y on the left. Then from there, we're going to plot the y-intercept. We're going to count out the slope. We are going to figure out if it's a dashed line or solid line. And then we're going to shade. So if it's less than, we're going to shade lower than the line. If it's greater than, we're going to shade above the line. Okay, let's try this thing. X greater than negative 2. It's an X line. So I don't have a y-intercept. My slope here is undefined. So I go down to negative 2. Is my line dashed or solid? It's going to be dashed. So I'm going a dashed line straight up and down, like so. And then where am I shading? Got to shade this way, so I'm going above. So any number greater than, so that would be that direction. Let's do another one. First off here, I want to solve for y. So I have negative 6x greater than or equal to negative 8x, whoops, I can't write today, minus 24. Now when I divide by my negative here, my sign flips. So I got 8 over 6x plus 4. Let's simplify this so that it's y less than or equal to 4/3 x plus 4. So what's my y-intercept? 4. My slope? 4 over 3. We have a solid line. We got that equal to part. And where am I going to shade? We got less than, so we're going lower. Okay, so we got 1, 2, 3, 4. My slope is 4 over 3. I'm going to go off the graph, so I'm going to go down opposite. 1, 2, 3, 4 over 1, 2, 3. Solid line, so I'm going to keep that as solid line. I'm shading below it because it's less than. Y less than 1/3 x minus 2. So I start at negative 2. My slope is 1/3. I got a dashed line here. And it's less than, so I'm going lower than. Start at negative 2. Slope up 1 over 3. Oh, and I literally just messed up. Dashed line. why you shouldn't do this in pen. It should be dashed. My bad. And then lower than, below. Okay, let's look at graphing absolute value inequalities. These ones are a little bit different. Again, we want the y on the left. First thing I'm going to do is plot vertex. Remember what our vertex was? HK. Then you're going to count the slope. Figure out if you have a dashed line or a solid line. I'm going to shade using a test point. I'll show you how that works in a second. So let's look over here. Y greater than -2, absolute value, x minus 3 plus 4. So my vertex is 3, 4. My slope is -2 over 1, so I'm going to be a flipped 1. I have a dashed line, and then we'll come back to the test point. So we got 1, 2, 3, 1, 2, 3, 4, down 2 over 1, dashed line, and then my test point. I like to use 0, 0 because it's a nice easy one, and as long as it isn't on the line, then you're good. So I'm going to do 0, 0. And watch this. So I'm going to plug it in. So 0 greater than -2, 0 minus 3 plus 4. Okay? So 0 greater than -2. 0 minus 3 is -3. Absolute value of that turns +3 plus 4. 0 greater than -6 plus 4. 0 greater than -2. Is 0 greater than -2? Yes, it is. So that means 0, 0 is in the place that I'm going to shade. So it's on the outside here. On the outside of this thing. Nice shading. That's terrible. Okay, let's do another one. My vertex, so I got positive and negative, so I got changes, remember? -1, -4, my slope, -1/2. I got a solid line because it's equal to, and we'll come back to the test point. So, -1, -4, down 1 over 2, down 1 over 2, solid line happening this time. And then test point, let's do 0, 0. So, 0 less than or equal to -1/2, 0 plus 1 minus 4. 0 less than or equal to -4.5. Is 0 less than -4.5? No. -4.5 is definitely less than 0. So that means it's not up here. It's got to be below this thing. What did we learn how to do today? I can graph linear and absolute value inequalities. There you go. That's a wrap on chapter 2.